I think we can start. So for today's presentation will be two speakers. My name is Cyprian and my co-presenter name is Joby, and we are both senior Android developers. I'm really glad to see so many people interested about this topic. Discussions about what kind of architecture have you used, why you are using architecture A and not B, or how you implemented this architecture are always interesting topics among the dedicated programmers. We are gathered here today to talk about the MVI and especially to see a concrete implementation recently used in production. For today, we prepare a brief introduction about the most popular architecture used in Android, trying to answer to the following questions. Why should we use an architecture in software development? What kind of problems you can solve using an architecture in software development? What is architecture? What are the most popular architecture? When did they appear, but especially since when they have been used in Android? What is the structure of the most popular architectures? We'll continue with an overview of the MVI architecture components, diagrams, interaction between components, pros and cons. Next, we'll go through our concrete MVI implementation in details. At the end, we have a Q&A session where we'll try to cover all your questions. Before answering to this question, let's imagine a world in which every programmer is coding using his own rules without respecting any agreed rules or principles. The resulting code would look exactly like the building in the picture. Difficult to understand, having a lot of problems, and very difficult to maintain. Over the time, programmers have encountered or are frequently facing with the same type of problems when it comes to design software applications. Using an architecture pattern is the right solution to solve all these problems, such as separation of concepts. In a world where the UI logic changes more frequently than the business logic, developers should have a way to separate responsibilities. One of the most common mistakes in development process is to write the code or a significant part of the code in one place, such as activity or fragment. But both the activity or the fragment are just glue classes that represent the contract between the Android operating system and your application. These UI-based classes should only contain logic that handles user interaction and operating system interactions. By keeping these classes as clean as possible, you can avoid many lifecycle related issues. Reusability. It's one of the main practices since the beginning of programming. Developers have been always focused on reusing code blocks, templates, functions, or procedures, and so on. Reusing the code saves time, resources, and the redundancy required to develop a software product. Using an architecture pattern helps the programmers to reuse the code, especially through separation of concepts. Scalability. Most of the time when creating a new product, MVP, most viable product, is used to see the profitability of the product over a period of time. And if it's proved to be profitable, the product is developed by adding new features. The cost and the time of implementing a new product or feature should be minimized. Therefore, an architecture should be easy to apply for both simple and complex products. Maintainability. Code maintainability is inversely proportional with the time spent by a developer to do a change and the risk to add new bugs. If we are trying to put this definition in other words, our code is easy to maintain if the time spent to do a change and the risk to break the code are as low as possible. The complexity of application is constantly increasing, so we need to create applications which are easy to maintain. An easy-to-maintain code must be easy to read, easy to understand, decoupled, and clear. On short, the maintainability of the code reduces the time required to implement the new changes. Ease of use. Like any other product, architecture should be easy to use and understand. Most of the time during a project, the developers are often replaced. Therefore, the training of new people to use an architecture should be simple and short. Testability. As we know, testing Android application may be often complicated because most of the time the classes are coupled with Android APIs. Proper usage of the architecture helps to independently test each module or each component. Reliability. All existing architecture ensure a certain degree of reliability on long term. Using an architectural pattern to create software application minimizes long-term costs. Adopting an architecture should be a long-term choice and not a short-term one because it's not recommended and is difficult to be changed very often. When we are talking or thinking about a software architecture, we can create an analogy with the foundation of a house. Once the complexity of the code grows, the changing of the architecture becomes really impossible to realize, exactly like the foundation of a house. Once the house has been built over the foundation, it's really hard to change it. But how can we solve all these issues? Do we have any good solution for all these issues? Yes, we have. So basically the best solution to solve all these issues is to use an architectural pattern. What is the architectural pattern? The most popular definition for an architectural pattern are general reusable solution to a commonly occurring problem in software architecture within a given context. Reusable design of software architecture at high level of abstraction. Fundamental structural organization schema for software system. A simplified definition in this case can be a guide, a set of rules generally accepted to design the software applications. Next, let's see a short history about the most popular architectural pattern used in Android. First one is MVC, Model View Controller. It was introduced for the first time in the 70s, 80s. It was accepted as general concept in the year 1988. It has been used in Android development since at the beginnings, 2008, 2009. MVP, Model View Presenter. It was introduced for the first time in the 90s. It has been used in Android development since at the beginnings, 2008, 2009. MVVM, Model View View Model. It was introduced for the first time in 2005. First Android MVVM implementation occurred in 2015-2016 implementation based on RxJava. It becomes much more popular for Android in 2018 when Android Jetpack has been released. MVI, Model View Intent. First Android MVI implementation are dated from 2016-2017. Just taking a look overall this architectural pattern, we can notice some common components such as model or view and some variable components such as controller, presenter, view model, or intent. On the next slides, we'll see that the differences between the common components of the architecture pattern vary just a little. Next, let's talk a bit about each of these patterns, focusing on components, interactions, pros and cons. First one is Model View Controller. The model is the central component or the brain of the architecture. There are different opinions related to what actually the model means or which are the components of the model. The most popular definition in this case is that the model manages the data or the APIs and contains the business logic. The view is a visual representation of model data in a predefined format. For MVC, the view model can be XML files, activities, fragments, or even native views. The controller. The controller is just a glue which ties the view with the model. It is the component that is notified by the user's behavior and updates the model accordingly. This may be an activity or a fragment, but also can be a completely separate class that does not extend any Android class. Let's see some interaction between these components. The user uses the controller. The controller manipulates the data from the model. The model updates the view. The view displays updated data to the users. Let's see some pros for MVC. It's easy to use or implement because it has a long history behind it, more than 50 years in programming. Also, it's easy to learn. Let's see some cons. The main cause is separation of concerns because the controller is tightly coupled with the view or the model. Testability is another cons because the controller is tightly coupled with Android APIs, making it difficult to test. The controller maintainability because over the time more and more code is transferred to the controller, making it big and fragile and difficult to maintain. Next pattern is MVP or Model View Presenter. Also in this case, the model is the central component or the brain of the architecture. The model manages the data or the APIs and contains the business logic. Also in this case, the view is a visual representation of the model data in a predefined format. For MVP, the view can be activities, fragments, or even native views. Also in this case, the view implements an abstraction of its own, an interface. The presenter. Exactly like the controller, the presenter is the glue which ties the view with the model. Is the component that is notified by the user's behavior and updates the model accordingly. The presenter is a completely separated class that does not extend any Android class and which contains a view abstraction. Let's see some interaction between these components. The user uses the view. The view triggers an event in the presenter. The presenter manipulates the data from the model. The presenter notifies the view to display the updated data to the user. Now let's see some pros. Comparing MVC with MVP, MVP has a better separation of concerns between the presenter view and the model. The presenter may be tested much easier than the controller because it's not coupled with Android APIs and contains a view abstraction. The implementation is clean, clear, and easy to use. Let's see some cons. Exactly like the controller, the presenter maintainability is a cons because over the time, more and more code is transferred to the presenter, making it big and fragile and difficult to maintain. Next, let's take a look on model view model. Also in this case, model is the central component or the brain of the architecture. The model manages the data or the APIs and contains the business logic. The view is a visual representation of the model data in a predefined format. For MVVM, the view can be activities, fragments, or even native views. The view model, like the controller or the presenter, is a glue which ties the view with the model. The view model is completely decoupled from the view because it contains a binder, which automates communication between the view and the model. The view model has been described as a state of the data in the model. So basically, it is responsible for keeping the current state of the view. Let's see some interaction between these components. The user uses the view. The view triggers an event in the view model. The view model manipulates data from the model. The view model notifies the view when his state has been changed. Let's see some pros. Comparing MVVM with MVP or MVC, we have a better testability for the view model because it's completely decoupled by the view. The view becomes really dummy and clean. Also, MVVM facilitates the parallel development of the user interface. Let's see some cons. Unjustified use, for example, for the application with very simple user interface. Data binding can be really hard to debug even if it's easy to use. Also, using data binding in complex and large application may generate a quite considerable memory consumption. Another cons is the view model abstraction. So basically, in large application may be difficult to be done. After a short introduction through MVC, MVP, and MVVM, finally it's time to talk about our main topic, MVI pattern. Also in this case, the model is the central component or the brain of the architecture. The model manages the data or the APIs and contains the business logic. In MVI, model also represents the state of an entire application, the state of an entire screen, or even the state of a single view. The view is a visual representation of model data in a predefined format. Also in this case, the view can be activities, fragments, or even native views. Intent is the component which takes the user input and transforms it in something interpretable for the model. Basically, it's just an event which triggers an action to manipulate the model. Let's see some interaction between these components. The user uses the view to trigger an intent. Based on the intent, an action is created to manipulate the model. The view is notified when the model has been updated. The new model is displayed to the user. Let's see some pros for MVI. MVI has a better separation of control between these components. MVI has a single source of truth for the state. If for MVC, MVP, or MVVM, each component could have its own state, the MVI has the model representing the state. MVI is easy to use, easy to debug, easy to maintain, and easy to scale. Let's see some cons. It's a very new architecture. Because it's new and because it's based on reactive and functional programming, MVI is not easy to use, learn, or implement. Another big cons for MVI is that right now exists too many different approaches, which means that it's not really easy to understand. Now let's take a look to the MVI from a mathematical point of view. So basically, using a mathematical point of view, we can describe the model view intent as follows. The intent is a function which takes the user input and translates it into something that will be passed as parameter to the model function. This can be user interface events, such as click events, application events, such as onActivity result callback, can be a simple string or a more complex data structure like an object. We can say that we have the intention to change the model with an intent. The function view takes the model written from the model function and gives it as input to the render method. Should be as dummy as possible. Should have only one responsibility. So basically just to render the model to the user. The model function takes the output from intent as input to manipulate the model. The output of this function is a new model, and it will be passed as parameter to the function view. Basically, the model function calls our business logic using an interactor, use case, repository, or something else, and delivers a new object as a result. In MVI, having the model representing the state solves a lot of common issues in Android, such as the state problem. In MVC, MVP, or MVVM, the business logic would have its own state. More than that, the presenter, controller, or view model, or even a view can have its own state. But in MVI, the model represents the state, and the state is unique. Screen orientation changes. In Android, screen orientation change is a challenging problem. The simplest way to deal with this is to ignore it. And we should just reload everything on each screen after the orientation change. This is a completely valid solution, but we also have other solutions like using a view model from architecture components. Navigation on backstack. It's another challenging problem in Android, especially when the fragment has been replaced with another fragment because the user has navigated to another screen. So in this case, the solution is straightforward. We just need to call the render method with our model to display the view to the user. Process dev. Sometimes when our application is in background, it's destroyed by the operating system. Most of the time, the best solution is to reload the whole screen, just like we are doing on the first start. Anyway, recently we can have other solutions such as using lifecycle view model with saved state. Immutability. We are not talking here about the advantages of the immutability, but we want an immutable model. Why? Because we want a single source of truth. We don't want the other components in our application to manipulate our state. Debugging and reproducible states. The unidirectional data flow ensures that our app is easy to debug. Wouldn't it be nice next time when we get a crash report from Crashlytics to be able to reproduce and fix the crash easily because all required information are attached to the crash report? But what means all the required information in this case? Well, all the information we need is the state of the model when the crash happened. Testability. Traditional MVP or MVVM improves testability in an Android application, but with MVI testing, it's even simpler. With the model representing the state, we can simplify our unit test and we can simply check if our expected model is equal with our current model. So we did it. Recently, we implemented our first version of MVI and use it in production. Next, we'll go in deep through our MVI implementation, explaining each component, showing some samples code and more. Joby, you are next.
Thanks. So I will share my screen. I guess you can see it. For the demo, we have implemented a very simple application, as it can be seen in the attached GIF. The application displays a list of movies where every movie can be set or unset as favorite. Apart from this, you can select a movie and navigate to a screen with details about the selected movie. Since this is just a demo application, we implemented only the parts that we needed. We didn't deal with the rest. The implementation, to implement the application, we use the following technologies, but note that we will not go into details of these technologies. We used Kotlin as the programming language. We used RxJava for reactive programming, Recycle View for displaying the movies list, lifecycle extensions, but mostly the view model, Toothpick for dependency injection, and Retrofit for networking. Next, I will talk about the general flow of architecture, explaining each step in detail. The first step is to send the UI events or system events. which are transformed into corresponding intentions and transmitted to the model. The model creates a new immutable state using the intent and the previous state, and this new state is observed by the view. Based on the new state, the view will update the UI. This way, the architecture follows the principle of unidirectional data flow. In other words, the data is transmitted in only one direction. Now I will present our implementation of each component. The first component is the intent. The intent refers to the intention of the user or system to change the current state, but not to be confused with the intent from Android. The intent is practically an event, with other words, a user or application intention to do something. It represents all user or system interactions that lead to changes in the current state. In our case, it is a sealed class. It can contain data classes if we need to transmit more information through the event, or objects if we do not transmit other information through it. The next component is the model, whose responsibility is to process the intent and update the current state. The first element of the model is the use case, which processes the event and generates the action to change the current state. In our case, this is an extension function on observable of event. It may return one or more actions. Its main responsibilities are to make API requests, to process data, to log information, and to navigate. In some cases, such as navigation, if there is no need to change the current state, we may not generate any action. The second element of the model is the action. As mentioned previously, the actions are the result of event processing. In our case, the action is a fundamental interface, is a functional interface. It converts, their only responsibility is to convert the data to a new state and to update the state. As you may notice, the new state is created by cloning the existing state and updating the properties. The next element is the state. In general, the state represents a screen of the application, as in our case, but it can also be the state of an entire application or just the state of a single view. One of the fundamental concepts of this architecture is the immutability of the state. The state is a data class. We recommend having separate states for different layers of the application. For example, the UI state, the state of the data received from the network, or other levels. The advantage of dividing the state into different levels is that we can filter the levels that will redraw the page. The last element is the view model, which is the bond between the elements of the model. In our case, we have used the view model for architecture components because it is lifecycle aware. Using an implementation with RxJava, we use the publish subject to broadcast the events. The view model also contains a reference to the previous state. And beside these, it also contains an observable that is observed by the view. We also have a send event method that makes the event emitter available to the view. Being the binder that bonds the elements of the model, the configuration of the flow is done in an Rx chain. Thus, we have the following functions. event to actions, a mapping from event to action, action to state, a mapping from action to state, and map to UI state, a mapping from the whole state to the UI state. Let's see the implementation of these three functions in more details. All these functions are extension functions on observable. Events to actions is the function that maps the event to use case. And the use case will process the data and generate the action corresponding to the event. Action to state scans the current state and together with the current action creates the new state. Here we used skip by one because scan also returns the initial state, but we only need the modified one. So we are skipping the initial one. Map to UI state helps to segregate the state, transmitting further only the state needed to refresh the page. In both cases, we will pass on only the distinct states. So far, we have talked about the elements of the model. Now we can move forward to presenting the last component, which is the view. The responsibility of the view is to observe the state and update the information displayed to the user. The first element of the view is the activity. The responsibilities of an activity in an MVI architecture must be limited. These can be maintaining the view model, emitting initial events, and those related to the activity. For example, in case of lifecycle events or other events called by the system through the activity, which can be callbacks like on activity result. It also links the state to the view. It links the view to the view model. And it does final cleanup when stopping and destroying the activity. The last element we are talking about is the view from Android. The screen is a list of movies that we implemented using Recycle View. The adapter used by the Recycle View, it is a custom one, containing a simple mapping between the state and the view holder. It also contains an event emitter, which can be used to emit the events of the view, for example, clicks, and they are observed by the activity. The view should have only one responsibility, which is to render the current state to the screen. Coming back to our diagram, the last step is the rendering of the screen, closing this way our unidirectional flow. Finishing talking about all the components and their elements, we can make a brief recap. The intent contains the event, the model contains the use case, the action, the state, and the view model, and the view contains the activity and the view from Android. On the previous slides, we have presented each component separately and the implementation of the elements of each component based on a general diagram. In order to see how we combine all the elements of the architecture, not just the components, we will also present a diagram with a concrete and detailed scenario from our application. The presented scenario will be loading a list of movies when opening the application. The first step is opening the application by the user. In the next step, the activity sends the event to load the movies list using the event emitter. The event emitter forwards this event to the view state. The view state is observed by the activity. The view state maps the received event to a use case, in our case, the one for loading movies. In the use case happens all the data processing, such as requesting data from the API, reading data from the database, etc. After processing the data, the use case returns an action to the view state. Then the view state will call the action2state function that updates the current state with the new list of movies. The resulting new state is returned to the view state. Due to the fact that the activity observed the view state, the resulting new state is also propagated to the activity. This state then is used to render the view. The only responsibility of the view is to update the UI. In this case, we can also notice that the flow is unidirectional because we started from the user and got back to him. Like any existing implementation of the MVI architecture, neither our implementation is perfect. Therefore, some improvements can be made. The first improvement that we thought about is to get rid of callbacks and replace them with an observer pattern in order to have a completely unidirectional flow. The second improvement we could make is to reuse use cases. This way we will increase code reusability. As you have seen in the examples, we have one state that holds everything. This state in real applications will increase a lot, and it would be advisable to be divided into several smaller states to avoid this issue. Another improvement we could make is better code structuring. Here we refer to the use cases and actions that we can divide into packages and packages based on features. And the last improvement we thought about would be to reduce the boilerplate code, such as the initial setup from the activity and the view model. As we have seen in the previous slide, our implementation is not perfect, but we hope that we managed to convince you that the MVI architecture is suitable for your projects too. We believe that it's time to start using the MVI architecture, which maps better on Android than the other architectures presented, and it follows current trends from the community, such as functional and reactive programming. We will continue to constantly improve our implementation to reach an optimal architecture that will be a foundation for future projects. That was it. Let's see if there are some questions. I think you can raise your hands or ask questions in the chat if you have any questions. So let's see, what questions do we have? One of the question is, okay, so the actual model is not just one layer, but maybe layers placed under the same name. Or did I get that wrong? Yes, so practically we can have also other states. So we have basically one state, one big model, but with smaller layers. So we have multiple layers. That's how we break it in multiple layers. And this way, it is much easier to use to refresh the screen only when it is actually needed. Hope it answers the question. The second question is, you did mention the MVVM architecture has a con about making the implementation too complicated for simple application. I also see this as a con in MVI. It can be, but you can keep it simple. I mean, you can keep it much simpler than the MVVM implementation, so that won't be a con in MVI. If you learn once how it is working and how to implement it, then it is very easy to use even in smaller application rather than, for example, MVVM. There is another question: where can I find the sample project code? We will try to check with our team if it can be published, and if we can publish it, then we will reach out to you with the sample code. There was also a question for this: if we have a link for the demo project. Like I said, we will try to find out if we can actually share it. What are some ideas for breaking up the God state into smaller states? Yes, we also talked about this, to break it into smaller states. For example, creating at least 2 different states, like we started with the UI state and the network state. This way, when you update, for example, only the network state, like when you receive only some replies from the network that actually won't affect the UI, and it does not need it to be displayed to the user, you do not need actually to update the UI. You only do your work, you save it in the state, but actually it won't be visible to the user. And when the UI state changes, then you update the UI. Okay, another question is, what other languages would you recommend for this patterns implementation? Since we implemented it on Android, we thought now only about Java and basically Kotlin, since this is the future of Android. But MVI was not only I mean, MVI was not invented for Android, so it can be implemented for any other languages. Okay, and see, for navigation, you use architectural components with nav controller. No, we do not use for navigation because we had only activities. We were not using fragments, but if you are using fragments, you can simply use architecture components with nav controller. I think I've answered all the questions. Cyprian, do you have anything else to answer, or did you see anything that I didn't answer?
No, I think you already answered to all questions we have for now. So maybe if someone else has another question, if not.
If that was all, then thanks for coming, and hope it was interesting. It was an interesting presentation for you. Thank you.